So this is a new function that we need to graph. Let's call this, we've been calling this h of x, correct? The new one we've been calling h of x is equal to, h of x is equal to f a of x, something. This is a is inside now. Before we had the vertical stretch, a and the vertical, what do you call it, stretch and the compress, right? When a is outside and a is a fraction, we got a compress, a is a number greater than 1, we got a stretch. But now we are looking like this, a is inside. Then, so we have the, now we are going to use the two rules, then, so rule number, I'm writing this little different, rule number 9 says, then h of x equal to fa of x is a, now in this case we are going to get horizontal stretch and horizontal, what do we get? We can get a horizontal, we can make a function horizontally stretch and horizontally shrink. Okay? Horizontally stretch and horizontally shrink. Okay? Horizontally. So then we are going to say then is a horizontal compression. What is compression means? Compression, horizontally compress means shrink, right? Compression if horizontal compression if A is greater than 1. If A is greater than 1, we get a horizontal compression. And rule number 10.
Where you get a compression.
Yes, this is the opposite of the other, right? If A is greater than 1, in the when it's outside, we get vertical stretch. Now we get horizontal compression when A is greater than 1. So it's the other way. Okay? Because now we are going to work with the x coordinate, not with the y coordinate. Okay? And what's the rule number? H of x is equal to f of a of x, whatever the a of x here, f of a of x, is a horizontal stretch if a is a fraction less than 1 and greater than 0. We are going to work with a positive way. Okay? Everybody understand this? Okay. So this is the two rule. Now we are also going to so how are we going to do this? This is how we are going to do this. We are going to, the transformation parts, we are going to move these. So we are going to make each x coordinate of y is equal to f of x. This is the, you take the x coordinate of y is equal to f of x and multiply by multiply by 1 over a. That's what we need to do. I'll explain this to you guys, okay? Remember we took the y coordinate and multiplied by a when it's outside. Now we take the x coordinate and multiply by what? 1 over a. That's why you get when a is bigger, if you multiply by 1 over a, you get a fraction, right? So you get it becomes a compression. It works the other opposite, the other way. You can look at, so this is how we graph h of x when graphing h of x. When graphing h of x here is equal to f of a of x, correct? This is what we are supposed to graph. Okay? Everybody understand the rule? 2 rules here, but we wrote it as 1. I'm going to explain this to you guys with an example. Question.
What does it say above make each? Does it say graphing? What is it?
When graphing.
Oh, when graphing, okay.
When graphing this h of x, we are graphing the new function. New function is the h of x that we are supposed to graph, but we are using the transformation, we are using the basic function and move the coordinates using these rules, right? So this is the 2 rules that we are going to use when the h of x function is given like this. You guys can give me an example for this? Let's say our basic function is y is equal to x squared. Let's take the easy one. This is the basic one. We have done every example, every rule for this function now, correct? We have done every rule for this function. So now let's work with an example according to rule number 9 and 10. Who would like to give me an example? Use rule number 9 and 10. Matthew.
Y equals 2x squared.
Very good. Y is equal to 2x. Instead of x, we have what? Instead of x is inside. So this is like this. This instead of x, this is x squared. Instead of x, there is a number with it. Okay? Or we can write, we can say, so this is rule number what? A is bigger, greater than 1, right? So rule number? Rule 9, example for rule 9. Can you give me an example for rule 10?
Y equals 1/2 x squared.
So this is rule number 9, rule number 10. Example for rule number 10 is y is equal to 1/2 x squared. Okay, so let's work with this real fast. So we will do example number, rule number 9, this example. So this is example number 1 and example number 2. We have 2 examples to justify our rule. Okay, so let's do this real fast. I don't have a lot of time. I'm kind of going to go fast on this, okay? Okay, so what do we have here? 1, 1, 2 and 4, 2 and 4. So here's my, this is the dotted one. This is y is equal to x squared. This is not the one we are supposed to graph, but we need to show that. Now we are going to do 2x squared. So what we have these rules, these points. What do you need to do to these points? What do you need to do to these points? According to the rule, it says take the x coordinate of each point and multiply by
2.
A is 2.
1/2.
Multiplied by 1 over a. See, the rule says multiply by 1 over a. Keep the y coordinates the same. Here x coordinate, take the each x coordinate coordinate and multiply by 1 over a, and you can write this, but keep the y coordinate keep the same y coordinate. Keep the same y coordinate. Only x coordinate you multiply by 1 over a. So what is the x coordinate here?
0.
0. 0 multiplied by 1 over a is, what is 1 over a?
1/2.
1 over a is 1/2, right? 0 multiplied by 1/2 is 0. So this point stays the same here. The next x coordinate. Next x coordinate here.
1.
1. We are keeping the same y coordinate. Okay? What is the y coordinate here?
1.
1. X coordinate is also 1 multiplied by
1/2.
1/2. 1 multiplied by 1/2?
1/2.
1/2. So 1/2 is here, correct? So this point, this is the new point. What is the y coordinate, x coordinate here?
2.
2. What do you need to do to 2?
Multiply by
Take 2 multiplied by 1/2. What do you get? 2 multiplied by 1/2?
1.
1. So 2 multiplied by 1/2 is 1. 1 is here. 2 multiplied by 1/2 is 1. So when x is 2,
Yeah, the first point,
First
I think
point.
that it should be on 1/2 and you put it on 1.
take the x coordinate, and multiply by, yes, sorry. So this is 1/2, right?
Yeah.
X coordinate is 1/2, y coordinate is 1. Thank you. X coordinate is
1.
1. Now the new one, x coordinate is 1. Y coordinate is
4.
same y coordinate. Y coordinate is 4 here. Same y coordinate. X coordinate is 1. Y coordinate is 4. X coordinate is on the other side. Same thing, multiplied by 1/2. 1 multiplied by 1/2. So it's 1/2. Y coordinate is 1. X coordinate is, here the x coordinate is 2. 2 multiplied by 1/2 is 1. Then the y coordinate is the same, correct? So the new graph is what? You guys see this, class? So what happened to the new graph? It's horizontally compressed. So this is horizontal. Now your compress means making it smaller, right? Pushing from both sides. Yeah. So then this one wider become narrow now. So this is horizontal compress. Keep the same y coordinate and multiply the x coordinate. So read the rule carefully, guys. If this 2 was outside here, then we only multiply the y coordinate and keep the same x coordinate. It's the opposite of this one. It's like horizontal shift and vertical shift, right? For horizontal shift, we have to have it in parentheses, whatever we are going to move, together with the x. Correct? It's the same thing. We have to have it in the parentheses to do the horizontal shrink and horizontal stretch. Everybody understand this? Okay, so let's do this example. I'm going to do it right here. So how will you do this one? What do we need to do now? A is 1/2. All you have to look at A. What is, we have to take 1/2 A, and we have to work with what? 1 over 1/2. A is 1/2. So what is 1 over 1/2? 2. Now A is 2. What 1 over 1/2 become 2. So what do you need to do to the each x coordinate? Because 1 over 1/2 become 2, so we have to move change each x coordinate to multiplied by
Two.
2. Each x coordinate multiplied by 2 according to this example. Example to example, the factor that you multiply can change, correct? You can see that, right? Factor that you multiply is going to change. So here we are multiplying by 2. Keep the same x coordinate. So this is x coordinate is 1 multiplied by 2, what happened? 2. So x coordinate 1, 1 become what? Y coordinate is 10, x coordinate become 2. So this is the new point here. Okay, what's the next one? Take the x coordinate here. 2 and 4 here. This is 2 and 4. Take x coordinate multiply by 2. Become what? 4. Y coordinate is 4 and x coordinate is 4. X coordinate 4, y coordinate 4. Are we following, class? Everybody?
Yes.
You have to agree what you're doing. What you're doing, it has to satisfy you. Okay? So I know you guys are following this really well because we have followed lots of rules now, 8 rules before this with the transformation. So this one, you guys see that? So now we can also get the other point by, because this is, we know symmetry, we can use the symmetry also to get the other one point. Or you can do the same thing here. X coordinate 2, y coordinate 1. X coordinate 4, y coordinate 4. So we get the new graph. So the green one is the new one. So what is this called? H of x is equal to 1/2 x. Do we have to get rid of the parentheses and do anything else? No. You can work with the other way also, but if you see this as this rule, just follow the rule here. Okay? We could have written this as 1/4 x squared and use the other rule also, because this will be outside the parentheses. Okay? Everybody understand? Okay, perfect. Okay, I'm going to give you guys one example. Okay, so let me write another example that questions, class? Questions? Everybody understand? Really good? Okay. So word to word, read the rule and understand exactly what the rule says and go through the example, and you're going to see how the example is working according to the rule. Okay. So I'm going to write a couple more examples here, maybe at least one, because I need to do some new stuff today. And even though the rule says a lot, but once we understand, it's not that much, right? Take the x coordinate here, multiply by 1/a and keep the same y coordinate. That's all you have to remember here. Even though this is 2 rules, it boils down to 1 rule, right? Here?
Yeah.
I separate it as 2 rules when a is greater than 1 and a is in between 0 and 1. So even though it's 10 rules, it's basically how many rules? 5 rules altogether, because the way we separated it looks like it is 10 rules, but it's basically 5 rules. Right? Okay, guys. so I want to give this example, another example number 3. So we did 2 examples, example number 3. Have you guys seen a graph like this before?
Yeah.
Yeah.
What is this graph?
Sine graph.
Very good, guys, perfect. Y is equal to, this is y is equal to sine x. We're going to talk about the pre-calculus class, we're going to do all sine x, cosine x, tangent x, all this, okay? So this is also function. This is a basic function in terms of the sines, cosine. This is the basic one you have to know, y is equal to sine x. So I'm going to show it to you, y is equal to sine x. This is the graph, one of the basic, but you don't have to know this to how to graph this. That's why I gave you the graph right over this is, but know this as y is equal to what?
Sine x.
Sine x. This is the graph of y is equal to sine x, goes like this. Okay? Pi over 2 is the radian measure. This is the degree. This is 90 degrees. Okay? Pi is 180 degrees. Okay? All right. Now, so now we are going to give example number 3 and 4 here. I'm going to write example number 3 and example number 4. 3 and 4 together. Okay? So example number 3, given this graph, you asked to graph h of x is equal to let's say 3 sine 3x, okay, h of x equal to sine 3x. Also you're going to, this is example number 3, and I'm going to write example number 4, h of x is equal to, let's put this as k of x, it's okay. K of x is equal to 3 sine x. Which one is example number 3? What rule? Rule number 9. Very good. So do we need to create a table of ordered pairs to this? And we don't even know how to create the table of ordered pairs, right? We are given a graph, all we have to do is, you see, you can look at the basic graph, and now without knowing how the graph looks like, graph is how to compute the number, you don't even have a calculator, you don't have anything, but we can do the transformation and graph this one. You see how powerful it is? Right? So how will you do? What do you need to do for the rule here? What do you need to do for the rule here? Sharon?
Multiply the x coordinate by 3, or by 1 over 3, sorry.
Multiply this is A is 3 here. Multiply the x coordinate by 1 over A is 3. Multiply the x coordinate by 1 over A. And what else we are going to do?
Keep the y coordinate.
Keep the y coordinate the same. So we know the 5 points or the 6 points that we are going to work with. So these are the points we are going to work with. You see that? Y coordinate we are going to be the same, x coordinate multiplied by 1 over 3. What happened pi over 2 multiplied by 1 over 3?
Pi over 3.
Pi over 2 multiplied by 1 over 3. Take pi over 2 multiplied by 1/3. What do you get? This is the factor we multiply.
Pi over 6.
Pi over 6. So now pi over 6 is, this is pi over 2, pi over 6 is, so we have to divide, this is pi, correct? You divide pi into 6 parts and take one of it, right? So this into 6 parts, so each one need to be divided to 3 parts. 3 parts here, 3 parts here, so this is like this. Pi over 6 and the same y coordinate. Good? What's the next one? So this one now is here. Instead of this one, we have this one. Pi, this is the x coordinate is 0, multiplied by 1/3 is the same, is 0. We keep the same y coordinate, multiply only the x coordinate. Take this one. We did this one. Take this one now. The next third, we did 2 points already. Third one. What is this point? Pi multiplied by 1 over 3. What is pi multiplied by 1 over 3? Pi, take pi multiplied by 1/3 is going to be
Pi over 3.
is going to be pi over 3. So pi over 3 is up to, out of 3, pi is here, right? So this you divide into 3 sections, correct? And take 1, pi over 3, and what's the x coordinate?
0.
Y coordinate is 0. Pi over 3 is here, so you need to mark this. Y coordinate is here. So now how does the graph goes? Same. Right? Okay, let's do this one now. So we did this, we have to do this one. 3 pi over 2 here, I'm sorry. 3 pi over 2 multiplied by 3 is going to be what?
Pi over 2.
Pi over 2. So now this is pi over 2. So at pi over 2, what will happen? It goes to -1. And the x coordinate is, y coordinate is -1. So keep the same -1. This one, pi over 2 at 2 pi, the x coordinate, multiplied by 1/3. 2 pi over 3. 2 pi over 3 is here. 2 pi over 3. Everybody understand?
Yeah.
So now, how will the graph look like? You see, the graph is look like this one. This one goes like this. We don't just show one cycle. Call it one cycle. Okay? Isn't it easier? So what is this graph called? Y is equal to,
Sine.
or h of x is equal to sine 3x. We don't have to worry about how to compute each number. The graph, whenever we see this, we change the x coordinate by a factor of, multiply the x coordinate by a factor of 1 over a. A is 3 here. So 1 over a is 1/3. Each x coordinate in here, all these 5 points that you're supposed to work with, 6 points, multiplied by 1 over a and what? Keep the same y coordinate. Very easy. Okay? Okay, let's work with this now. What do you need to do to this? What do you need to do to this?
Stretch it.
What do you need to do to this?
Multiply x squared.
Raise your hand if you know the answer. Explain.
Is it 8 times y?
Vertical stretch?
Vertical stretch. Vertical stretch. In here, vertical stretch means what? We keep the same
X coordinate.
x coordinate and multiply the y coordinate by a factor of
3.
a. A is 3. When a is 1/2 or a is a fraction, we multiply by 1/2, whatever the, right? So we get, so here, see how easy it is. We work with, so this is the original. So the original one is here. What do you do here now? Take this one. Y coordinate is this, same x coordinate, y coordinate multiplied by 3 goes here. This is 3. 1 multiplied by 3 is 3. When it's 0, it's here. Keep the x coordinate, -1 multiplied by 3. Got it?
Yeah.
Keep the same. X coordinate is the same. Y coordinate is 0 multiplied by 3 is 0 multiplied by 3 is 0. So do you guys see the points? Got it? Isn't this good? You can do this to any graph, because if you know the basic graph, you don't have to identify what the basic, if the basic graph is given as whatever, and then use the basic graph and given the graph that you need to graph, something like this, put a 3 in here or 2 in here or put 1/2 in here, right? Numbers could be different. As long as you know how the basic graph look like, you know how to graph the basic graph, you use the basic graph to do any other graphs. That's the part here. Okay? Okay, so this is, what's the name of this graph? H of x is equal to 3 sin x. Now do you see the difference here? This is a horizontally compressed. This is vertical stretch. Okay? I want you guys to, so example number 4 here, example number 4, we can write h of x is equal to, graph h of x is equal to sine x over 2. What kind of graph we are supposed to get here? What do you think? What is A here?
Horizontal stretch.
No, A is horizontal, it's going to be wider, right? It's going to be way wider than this one, correct? Keep the same y coordinate and x coordinate multiplied by 2. Because 1/2, A is 1/2, A is equal to 1/2. 1/2 multiplied by, you take 1, so what is the factor here? Factor that you're supposed to multiply, you need to determine that. So 1 over A is become 1 over 1/2 1 over 1/2 become 2. So keep the same x coordinate, sorry, excuse me, keep the same y coordinate and multiply the x coordinate by a factor of 2 to get this function. Okay? So I think you guys can do that. Work on this for me for homework for this problem. Maybe for classwork today you can, so work on this, okay? Maybe classwork, if I don't have classwork, I'm going to give this for homework. Turn this in, okay? Okay guys, so now I have to do a couple more things. Any questions from this? Everybody understood? Okay guys, so now let's do, okay. So we are going to, this is a test question. Test is this coming up Thursday. Test question. Example, y is equal to graph f of x is equal to x plus 2 let me write from this to first. F of x is equal to x plus 2 whole thing squared plus 3 and 2 here, or 4 here. Sorry guys, I'm going to change this. Put a 3 here, it's easier coordinates. Sorry about that. What do you see here? Can you do the transformation to graph this?
Yep.
Yes, right? Now we did a couple of examples last class meeting where we are going to do more than one transformation. We're going to do 3 transformations at the same time. If I put a -1 here, it's going to be another one. If you have a negative sign here, it's going to be what? Reflection through
Yeah, exactly.
what axis?
Yeah.
X-axis. Okay? Reflection through x-axis. So we know. So here we are going to graph this using transformation. Using transformation. Now we can graph this using we can simplify these and make it similar to convert this to look like ax squared plus bx plus c and then graph also, but that's not the way we are supposed to do for this. Use only the what? Transformation. So we are going to, it says in the direction, use methods of transformation. So follow the direction. What are you thinking? Which is your parent function? Y is equal to x squared. So y is equal to x squared, this is the parent, basic one. This is what we are going to take. Okay, so we are very good with this, guys. So we are going to graph this. One, 2, 4, -1, -2 and 4. These are points. Know your 5 points. Okay, so this is x squared. What do you need to do? Remember I said it's easy to remember as PEMDAS. You do the parentheses and then the exponents, multiplication, then even the division, if you have, you can consider as multiplication, right? And then addition, subtraction at the end. Okay? Okay, so this one, let's work with this. What do you need to do?
Horizontal shift left.
Horizontal
Left.
shift to the left. Very good. So take each point to the left too. This 2 here. Each point, so I'm going to do all my transformation together. To the left 2 and to the, after that, I need to do the multiplication, right?
Yes.
So if I do this one first, I can do the graph here first, right? So 2 to the left, this one, 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 2 to the left. So this graph is here. Now what do you need to do?
Multiply y times 3.
You do the multiplication. What kind of shift is, what transformation is this? What is it called? Vertical stretch. Everybody follow it, right? Vertical stretch. There's a lot of language here, vocabulary that you have to be familiar. The rules, your tools. Okay? So vertical stretch. Each one multiplied by, each point multiplied by what?
Y times
3. What coordinate? Y coordinate. Vertical stretch is y coordinate. We did the example with this, only with this number. So now, do the vertical y coordinate here, multiplied by 3 is the same. So this, x coordinate the same, y coordinate 0 multiplied by 3 is 0, x coordinate. Y coordinate is 1 multiplied by 3 is
3.
so x coordinate 1, my y coordinate is 3. This point, x coordinate, y coordinate is 4 multiplied by 3 is 12. So 12, somewhere here. This point, y coordinate is 1 multiplied by 3 is 3, and x coordinate is the same, y coordinate is 3. This point, y coordinate is 4, right? Multiplied by 3 is, what is it? 12. So here this one, so far we have this. You guys see this class?
Yes.
So this is a vertical stretch. What is the rule for this function? Only y is equal to 3
parentheses,
x plus 2.
squared.
If you graph only this, that's what we get. We do the horizontal shift and then you do the vertical stretch. Are we done? No. What else we need to do to this graph now?
Go up 4.
Two for,
What?
Up 4.
Up 4. We have to do the shift. We have to do shift plus or minus you do at the end. After you clear the parentheses. Okay? Good? Okay, so how will you do that? Take each, you work with these 5 points. You have to be very careful. You work with these 5 points now. You have to know what those points are. You need to work with graph paper when you do the homework. So now take each one, move 4 units to the, up. So this one goes 4 unit up, is here, 4 unit up. Is here. Okay, I'll use black here. So this is this. This one goes 4 unit up, so this is 4 unit up going to be what? 8. Right? So this is what? What is the coordinate here? 1 and 8. This one goes 4 unit up, is going to be 3 and 4. 4 unit up is 8, 3 and 8. Right? And this one 4 unit up, same x coordinate. This one, x coordinate is 1. This one, what was the x coordinate?
That one was 0, 12.
0, right?
yeah,
0, 12.
Yeah, 0, right? 0 and 12. So this is going to be 0 and
14,
0 and what?
14,
16.
12 plus 4 is 0 and 16. So it's not because, so this one is way up, okay? So here way up 0 and 16. So now guys, the graph is going like this, right? Like going up, okay? So this is the graph of y is equal to f of x equal to 3, this graph. This is this graph. Okay? Now I could have done this. I'm going to take this point, let's work with this point. What is this point? 0, 0. I do the horizontal shift first. Look what I'm doing. Horizontal shift means 2 to the left and then multiplied by 3 and then move 4 unit up. So final point end up here. You see that? I can do all together. So I did one of this. This point I already focused on that. Let's go this point. This is what? 1 and original this is 1 and 1. Move to the left 2. Multiply by 3. What is it going to be?
3,
Y coordinate multiplied by 3 is 3. Correct?
yes,
So multiplied by 3. Move here multiplied by 3 here, right? So this is the y coordinate multiplied by 3. Add 4. Add 4. This is supposed to be 3, guys. I read it as 4 here. I'm supposed to write as 3, right? Because this is 1, 2, 3. 4 is here. So I'm sorry, I have to correct this. So multiplied by 3 end up here. Add what? 4. 3 and there's a mistake here, class.
7.
Because I thought it was 4, I made a mistake reading. 7. So 3 plus 4 is 7. So what is this point? 1 and
Negative 7.
1 and 7. You see that? So this point, 1 and 1 become what?
Negative 1 and 7.
Negative 1 and 7. Very good. Negative 1 and 7 because move 2 is negative 1. This point is negative 1 and 7. Okay, let's work with this point. This is 2 and 4. Let's work with this point. So I marked it, 4 is supposed to be here. Okay, okay, so let's do this. What do you need to do? Move 2
To the left.
to the left. So 2 to the left, x coordinate is 0, y coordinate 4. Take the y coordinate multiplied by 3. It's become
12.
12. So y coordinate is 0 and 12. So we have to go up to 0 and 12 here. 0 and 12 is somewhere here. 0 and 12. Add 4 to that.
16.
0 and 16 up there. You see that? So this point also we worked with this one, this one, this one. We did all 4 transformations. Nobody understand?
Yes.
Okay, now what? What is remaining? This one?
Yes.
What's the coordinates here?
Negative 1 1.
Negative 1 and 1. Move to. It's here. Right? Multiply by 3. Multiplied by 3 become what? So take this one, we are working with this one. We work with this one, work with this one, work with this one, work with this one. Now we are working with this one. Right? No, we are working with this one. Sorry. Huh? So negative 1 and 1 multiply, move 2 here, multiplied by 3 become what? Negative 3 and 3. This point is negative 3 and 3. And then multiplied by, move up. Move up. So that become negative 3 and what?
7.
7. This is negative 3 and 7. That's easier, right guys?
Yes.
So because we did lots of graphs here, it's kind of little, it looks like a lot here, but you guys know what we are doing.
Yes.
Okay? Take this point, do the same thing. We are repeating the same thing to every point. Take this point. No, yeah, this is the other point on the original graph. Move 2 to the left. So that's going to be 4, negative 4, and what? Negative 4 and 4. Right? Multiplied by 3, the y coordinate, so it's become negative 4 and 12. So negative 4 and 12, somewhere here, multiply, add 4, correct? So what's the last one?
Negative 4.
Negative 4 and
16.
16. Very good. You guys are really good. You're following. So see the 5 points on the new graph? Sorry, it's not looking very proportional here because there's two, I tried to show the same,
It's too much.
all these graphs at the same coordinate plane. Okay? If you want to show these two, that's fine, you can show it. If I ask to show these two, show each transformation, you need to show it. So you need to do both ways. Or if I ask, get the final graph with the transformation, all apply together, you can do this. But follow the order.
If there was also a reflection, you would still do horizontal shift first, then the
Yes.
reflection.
Now when you do reflection, you could have multiplied by -3
Right.
and then you get the coordinate down here.
Okay.
Okay? So it's not working as a separate rule.
Right.
Okay? But you know, you can also, after you do this whole thing, now you want to do reflection. If it's -3, you do the reflection at the end. First you do this, and what's the reflection of this? Take each point, reflection is here, correct? Take each point, reflect, so the reflection will look something like this, of this one.
But then you still do the addition after the reflection. Like +4, like if you want to go vertically up, then you.
Yeah, now, if you, there's two ways of doing this. If after you do this whole thing, yeah, first we need to do the reflection here, okay? And then move up 4. You do the reflection first, yes, and then move up 4. So this is the multiplication rule. So if you have a -1 here, you do the reflection first here, okay? And then move up 4. Okay? You guys following that? With the reflection rule, guys, if you have reflection here, you do this negative part first, okay? Because it's like multiplied by -3.
But you still do the parentheses first. You'll do the
Do
horizontal.
the parentheses and you can say multiplied by -3. So then you get the reflection of this graph. Multiplied by, this is the graph, you get the reflection of this graph. Okay? And then you move up 4. Okay, it's everybody okay? So on the test you might get something like this graph. I'm going to make this very simple, very similar to this. So what's the example I can give you guys? F of x is equal to what? Can I use absolute value of x?
Yes.
Instead of plus, I might have minus 2 plus 3. Right? This could be a test question because I did this one, similar. I can put a number different. I'm not going to, when I give 4, you need to follow 4 of these, 4 rules here. I'm not going to do rule number 9 and 10, okay, for here. It's going to be a lot. This is the most you can. Now, if you say something like this, test question, something like this. You can do this, right? Or something like this. What do you need to do to this? Move to the right one. Each point move to the right one, keep the same y coordinate, horizontal shift, and then multiplied by negative 2, or you can consider this multiplied by positive 2 and then take the reflection of that point. Correct? So you can do that, and then after, if it's just this one, you don't have to worry about the shift, vertical shift.
Yes.
At the end, if there's a vertical shift down here, you take this graph and move down. Okay? Everybody follow that? So for giving problems, you will have problems with rule number 9 and 10. Problems with rule number 9 and 10 will be separate problems like the one that I gave for sin x. Okay? But this is definite test questions. Definite test questions.
Both of those, right?
Huh?
Both of those problems?
Yeah. I will have something similar to this with x to the 3, something similar to this with squared or with square root x. Okay? You see. So you're familiar with this. Okay, so you guys copied the homework problem? I think I'm going to give this for homework. Okay? Okay, so let's do 3.2.7. I don't have time to cover. Okay, so let me see. So guys, see, I plan to do a classwork. I don't have time. Sorry. So I'm going to look at here. Let me randomly pick one here. Okay.
That was homework.
Oh, this is homework. Oh, homework you don't have to turn in. You need to turn in the practice test. Everybody need to turn in the practice test. Okay. So let me write something. I'm just looking at this. Test on Thursday. Test number 2. I didn't give you guys a practice test on this, but you guys pretty much know thoroughly what to expect. 2.1. We did all basic beginning algebra stuff, right? How to graph a straight line, how to find the equation of a line, right? 2.1 basic stuff. So all those 2.1 questions are going to be what I covered, right? So definitely it's going to be find the slope, find the equation of a line. Find the equation of a line. Of a line given some information. Remember we did this? So first you use the information. Maybe sometimes you have to find the slope if the 2 points are given. Use the slope to find the y coordinate, y-intercept, or you can use the slope intercept, find slope formula to find the equation of the line. Okay? And then we also, I said find the equation of the line, graph the line. Graph the line. So, problem like this. Graph the line part you already know, right? 2.1 questions like that. Find the slope, so this could be the slope one, okay? So you get the slope part. Okay, now, so we have find this, okay, that's too quick. Find the slope intercept from equation. Okay, another problem on this, given some information, it could be, information could be line passing through, line parallel to another line, right? give us some information, find the equation of the line, it could be, find the equation of a line which is parallel to or what? Perpendicular. Parallel to or perpendicular to another line, second line. This is the second line. There's a second line is given. Equation of this line is given. We need to find the equation of this line which is passing through a given point. We discussed this. Okay, so these three problems are there. Okay, problem number 4. Problem number 4, we graph. So this is 2.2. 2.2. This is between problem number 4 and I did together like 2.2 to 2.4. Okay? In my class discussion, I did 2.2, 2.3, 2.4. I went back and forth, remember? Okay, guys? So 2.2 through 2.4. What did we do? Function. Know what is a function? The definition of function. How many ways we gave a definition of function? You need to know all ways, all the way, all. What's the definition of function? We said set of ordered pairs. What else?
Each X only has one corresponding Y coordinate.
Yeah, that's the definition I gave in terms of words, right?
No.
Right?
you give the
Set of ordered pairs such that each X coordinate
only has one Y.
you can't have two same X coordinate with different Y coordinate. Also, we can give a function in terms of graph. We can give a function in terms of,
Equation.
what is it?
Equation.
Equation, like formulas like this. This is an formula. Function in terms of equation. Also, we say function in terms of
Standard form.
function machine, right? Remember the input, output, function machine. Also, we said function in terms of, at the end, different time I gave function in terms of what? Arrow diagram, very good. So I can give you an arrow diagram and ask whether this is a function or not. You look at the arrow diagram and I can also tell you guys to create an arrow diagram with two sets of ordered pairs, two sets of numbers, okay? That is a function. Are you guys following? So you can say one set as 1, 2, 3, 4 and the other set as A, B, C, D and put your arrows, domain to range, how the arrows should go to make this arrow diagram a function. Okay? All arrow diagram, if it's not a function, it's a relationship, but we want to get certain restriction where our arrow diagram is a function only. Okay? Good. Okay guys, you have to give me a few more minutes. So we know functions on all ways, so make sure that you guys know all these 5 or 6 ways that we wrote what is function. On the quiz I gave you, I asked you a certain problem. Write a function in terms of set of ordered pairs. So use the definition of what? Ordered pairs to write a function. Now on this case, if I say write a function in terms of arrow diagram, can you guys do that?
Yes.
Yes, because we have done arrow diagram definition really well, okay, in terms of what is a function. You don't have to describe it, you just draw an arrow diagram. Got it? Okay, good. Okay, number 4. Number 5. What is number 5? After function, we are going to, given a function, we did this all these problems. Given a function, I have all rules given, find what? Dn. You guys did this for domain and range. Mostly I'm going to ask domain. We did this for what? Basic functions. We graph all basic functions and give domain and range. And if it's coming with square root, the domain, you know to use the restriction. I'm not going to tell you how to use the restriction. If it comes as rational functions, you know to use restriction, like f of x is equal to perhaps 3 over x minus 2. What's the domain here? X cannot be equal to 2. So we know what to do to all real numbers on the number line except 2 is missing. We can't use 2. If 2 is there, this whole function become what? This whole function become undefined. Therefore, we have to take out 2 completely and use the other. So you need to know how to use your domain range. Okay? So question?
For a problem like that, you would just give the domain, right? Because I think we will.
Yeah, no, don't, no, yeah, I'm going to ask domain, yes, okay? So right now, certain problems I'm going to ask range, okay? Now this is domain and range. Number 6, we also know how to, number 6, how to what? How to? So how many basic functions we covered in this class, in this chapter? 6. There are more basic functions that you're going to cover later. We are going to cover in next chapters. But this 6, you're perfect on this 6 now. If anybody cannot do these basic 6 functions, you might as well drop the class, sorry, okay? Because there's no point. I mean, everybody in this class, you're really good at this. So know how to graph the basic ones. Because if you don't know the basic one, you can't do any of this. Remember how hard is this? Can you do without the basic ones? No, you can't do it. So know your basic ones, all basic functions. These are test questions. So for an example, I can say graph f of x is equal to 1 over x like I did on the quiz, right? Or x squared, or square root of x, or absolute value, all those basic functions, right? So this is so far, it's very easy, what we covered, right? Number 7, so what is number 7 can be? What is, after the basic functions, what did we do? This is a very good practice test. I'm looking at, what's the, yes,
Even
Yuki. Okay, so what's the next one we do? We did. Couple more minutes I have. What? Yes, we need to, given a function, determine whether the function is odd function or even function. So that's odd or even. Odd or even function. Odd, even, or either, right? Neither. Right? So this we know how to. For odd function, what's the rule we are going to use? F of negative x, right? And always we are going to check for f of negative x, right? F of negative x is, we can write this as f of negative is f of this, then this is odd, right?
Yes.
Or if you can write f of negative x, but you have to show this algebraically. It's the same as f of x, then this is a even function. So there will be, I spend a lot of time on not the even function. Number 8. What's the number 8 we did? Guys, I'm rushing.
Average.
What is it?
Average.
Yes, average. This average rate of change. So average rate of change. Average rate of change problem. Very easy. We did this. Okay. Look at in your note. Number 9. Piecewise function. Piecewise function. Remember the piecewise function, this is there's 3 problems in, there's 3 graphs I did with 3 graphs. Remember, look at the domain range. I'm looking at one of the examples, similar example. It's not difficult. You already know how to graph this. So piecewise function, number 9. Number 10. Remember the different quotient? How to calculate the different quotient? Right? Find find, this is easy, f of x plus h minus f of x OH. We did this different quotient, right? So that's number 10, different quotient problem. What is the next one?
Increasing, decreasing, and constant functions. Oh, relative maximum.
Relative maximum minimum, perfect. Relative max and relative, that's so easy, right? Relative max and minimum. So find relative max and minimum, number 11, relative max, relative min, right? Relative max and min. What else? Piecewise function. Okay, the other one is all what we did the end, right? Transformation.
Yeah.
Use transformation. Use transformation and graph. Graph the given function, whatever. So I'm going to give about 5-6 problems on this. At least 6 problems. Use transformation. Okay? And graph this. Anything else, guys?
Wait, do we need a graphic calculator?
No! Are you kidding? You're kidding, right? So you know, we used all these techniques to graph. We can't use graph. You can't even bring a graphing calculator. You can't calculate only scientific calculator. You can't use a cell phone. So we did lots of similar. We spent like 3 weeks doing the transformation, right? So you guys, about 20 problems. You see, I said altogether about how many problems? 20 problems.